Part D says to use the Taylor series for f about x equals 1 to determine whether the graph of f has any points of inflection. And so I've shown f, the Taylor series for f of x there, and the first few terms of it. Well, in order for something to have, for a function to have a point of inflection, then there must be a change of sign in the second derivative. And since the derivatives exist for all of these, derivatives exist at all different orders for this function here, we really need to find a zero derivative. Now it's going to be hard to show with a series whether the second derivative changes sign, but we'll get to that, well, we'll cross that bridge when we get there. So first of all, we need the first derivative of f, and that will just be the term-by-term derivative. Derivative of 1 is 0. Then the derivative of x minus 1 squared over 2 factorial is going to be 2 times x minus 1 to the first over 2 factorial plus 4 times x minus 1 to the third over 3 factorial, etc. We can see that there definitely is a zero first derivative when x is equal to 1, because placing x equals 1 in there will result in all of those terms becoming 0. But we'll continue on to the second derivative. The second derivative, again, we're just going to take the derivative of the first derivative. Now, since the first term will now become 1 times 2 times x minus 1 to the 0, which is 1 over 2 factorial. Second term will be 3 times 4 times x minus 1 to the second over 3 factorial. And just from this we can see that the first term will be 1. And regardless of what the second term is, that doesn't really matter here. We're going to have 3 times 4 x minus 1 to the second over 3 factorial. There is no value, since these are all positive terms here, even when x is equal to 1, everything after the first term will zero out, but you'll still be left with a 1 there. And what that's going to tell us is that the second derivative of f is greater than 0 for all x. Therefore, there is no point of inflection. And as I said, that's very convenient that there isn't one, because it would be hard to tell whether or not the sign changed in between or between on either side of a particular point. So that's going to do it for this. We had our original function, we found the first derivative, we found the second derivative, and we showed that the second derivative would be always positive. No value of x would make it equal to 0. Therefore, there cannot be a point of inflection there. And that does it for this problem.